All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying, let's determine the angle between side AB and the x-axis. Need to balance the object on point A. So really what we're trying to do, if we were to sketch a quick picture of this, is come in and say, I can start lifting this object up. As I do that, it's going to turn and rotate and get to something that starts to look like this. When that balances right here on point A, what's my angle between the x-axis and side AB? So this is still point B up here. What's my angle theta? So if I'm doing that, what can I say? Well, for something to balance, where should its center of gravity be? That center of gravity has to be right above the point we're balancing at. My center of gravity is right there. If that was to either side, if I had that to the left of A, we would rotate to counterclockwise and fall down. If it was to the right, we'd rotate clockwise and fall down. But if my line of action of the weight passes through point A, we cause no moment about A, we're going to be balanced on A as a result. So really, I just need to find my center of gravity, and I can work through this. So if I'm doing center of gravity for this, if I get no change in material, that's the same as my center of area. So let's just deal with center of area. So I could come in and split this into pieces. Really, it's two rectangles in here, no matter how I want to split that up. I could do this the three ways that make sense to me would be to say I could have a big square or big rectangle right here. We call that piece 1. That splits at this point. And a long skinny one, shape 2. That's what I'm going to end up doing. It would be the exact same amount of work, though, if I said I have a long skinny rectangle that goes 13 inches and then a smaller rectangle stuck on top of it. Two shapes there. I could work through that. Or I could come in and say I have a rectangle, a positive one, that goes 13 inches over, 3 inches up, shape 1, and subtract out a negative rectangle from there, shape 2. No matter what, though, I'm using two shapes. Just pick something and go with it. Our centroid problems oftentimes have a lot of valid solution paths that we could go through. We just want to pick something and go with it. So I picked shape 1, shape 2, how we have it laid out here. Let's come in and try to set that up and find it then. So I need to make a centroid table. Always make a table for centroid. It makes our work really easy to follow. Things just look nicer. So what's my area number? Will be my first column in here. Area number. And I broke that into two pieces. I need a shape for or a row for each. So shape 1, shape 2, and then I'll have a summation row at the end of that. From there, I need to know what's my actual area. So it's the area of these pieces. And that'll be in square inches because our units were in inches. My next column, I can say, if I'm getting centroid, I need an x tilde and a y tilde. So x tilde in inches and y tilde also in inches. With those known, I can multiply them by the area. I'll get an x tilde a in inches cubed and a y tilde a also in inches cubed. So we're just going to fill in this table, inches cubed. So just a couple rows, a couple pieces to fill in here. Again, what we're working towards with our centroid is our two formulas are going to get us our x bar is the sum of our x tilde a, or the x bar distance to the centroid of each piece, divided by our total area. Some people write that just x bar 1, x bar 2, x bar 3. Exact same idea. And a y bar. Y bar is the sum of my y tilde a, or my y bar n a, divided by my sum of my areas. And we're really setting up these pieces in here so I can make those equations really easy. I'll have my summations at the bottom. I can get everything busted out then. Let's come in and do this. So my first shape, area 1, is a rectangle. It's 5 inches wide, 3 inches tall. I would tell you to fill in your formulas into here. It makes it way easier to follow your work. Your professors will be a lot happier with you. 5 times 3 gets you to 15. It's also a good habit to be in as engineers, to fully document your work, and it's not hard to fill in the numbers. So show your work in here. Shape 2, we're told the entire base from A to B is 13. From A to where we step in is 5 inches. So 13 minus 5. This distance along the top is going to be 8 inches. So we actually know that distance in here, 8 inches. So let's come in and get my area. I should have base is 8, height is 1. 8 times 1 gets me to 1. Or sorry, 8 times 1 gets me to 8. And adding that up, 15 plus 8 is 23. Then I can go to my x tilde. So it's my x distance from the y-axis to the centroid of each piece. I'm going to estimate where those are at. Just put a blue dot in here. So for shape 1, we're measuring to there. For shape 2, we'd be measuring to about right there. So it's my x distance from the y-axis to shape 1. It's just half the width of it. Half of 5. 5 halves. We're at 2.5 here. For shape 2, I'd go from the y-axis in 5 inches. Gets me to the beginning of shape 2, where my centroid formula applies. And then I can go half of the width. 5 plus half of 8. 5 plus 8 halves gets us 5 plus 4 is 9. And I don't have a sum of my x tilde. I have some of x tilde a, but not just x tilde in here. Same for y tilde. So I don't need to add them up. Let's get our y tilde then. Both of these shapes sit right on that x-axis, so I can just directly do half of their height. So for shape 1, it'd be 3 halves or 1.5. 3 halves, 1.5. For shape 2, it would be 1 half or 0.5. Then I can just multiply columns together. X tilde times my area. 15 times 2.5 is 37.5. 8 times 9 is 72. And I have a sum of my x tilde a. Adding this up, I'll get 109.5. And y tilde a, same idea in here. What's my y tilde times my area? 1.5 times 15 is 22.5. 0.5 times 8 is 4. Adding those up, I get 26.5 cubic inches. And that gets me enough. I can find my x bar and y bar. Let's go ahead and find those. Then we'll talk through how to use them in here. Looking at this picture, I would have a hard time with that. We'll draw a slightly different picture. We'll redraw that picture, but label our angle differently. And it should help us with that. Let's find x bar. So my x bar is going to get us to my x tilde a, 109.5. 109.5. Divided by my total area, 23. Or x bar is 4.76 inches. And y bar is my y tilde a, 26.5, divided by my total area, 23. This is going to get me to 1.152 inches. So I know my centroid location. Let's come in and draw that in. If I just drew my general box or my general object that I had, I'm finding this object. And we just found that the centroid is at 4.76, so almost all the way across that first shape, 1.152, just a tiny bit past the top of that first shape. Or we could say we are right about here, just as a loose estimate. That is 4.76, comma, 1.152 are our coordinates here. If I were to come in and say I'm trying to rotate this until my center of gravity is above A, well, this is my center of gravity. I now know where it's at. If I made a line that went from A to the center of gravity, I could come in and say, in addition to this being my angle theta, I could just say, well, let's rotate that line until it is directly over A. This would also be my angle theta that I need to rotate that. If I rotate it so A goes and is now straight above A, I end up with this exact same angle. But in that, I'm really getting, I can use the inverse tangent. Theta is the inverse tangent of, in here, my opposite side would be that x dimension in here, 4.76, divided by my adjacent side, which would be the y distance in here, adjacent going straight up and down, 1.152. We're doing x over y because we're measuring from vertical for that angle when we actually know our coordinates. This is going to get us that my angle, theta, should be equal to 76.4 degrees, which is our final answer in there. Technically, we could expand this to any object we want to take a look at. If I could break it up into pieces, find the centroid, I could figure out an angle to rotate this to actually figure out how to balance anything. But we'll go ahead and wrap up there. Hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around, watch some more videos. Let's get you an A with JJ.